Oh man, Wendell, have you seen the time?
It is Rant 30, and it's long overdue.
It is long overdue indeed. So Intel, they love profit and they love market segmentation. The first thing we're going to mention right now is that Intel has a lot of silicon that's extremely similar, like the i7s and the Xeons that are Skylake. Very, very similar. Then they have the K parts, which have an unlocked multiplier, and then a non-K part. Very, very similar. It looks like most of the segmentation there is done to maximize profits, giving you different sets of features on the same essential product, forcing you to pay more if you want overclockability or if you want, different
Well, now
things.
wait a minute. Those are fighting words you're lobbying. Why do you say that? Because you couldn't previously overclock the base clock with it, just wasn't a thing. But now it is with Skylake.
So a lot of the different vendors out there started making their own versions of motherboards or their own motherboards that made it very easy to overclock these non-K parts. So you could save a couple dollars, get the exact same performance because you're still using almost the same exact CPU, and you're able to achieve an overclock that normally would only be able to be achieved with a K part. Well, Intel's decided that they better push out some microcode after the fact. So all the cows are out of the barn, and now they're like, shit, we need to close the gate right now.
So the microcode is just a mechanism to fix problems with the CPU, fix stability problems, fix other problems, but Intel has the keys to the kingdom. They produce microcode updates. The microcode updates are sort of published in binary form. You can look at them and see what they do. So there is some transparency there for the ones that are published. The microcode can be loaded by your BIOS. It can also be loaded by your operating system. Linux has microcode built into the Linux kernel. Windows updates sometimes include microcode updates. The microcode updates for the CPU will accept microcode updates as long as they're signed by Intel, basically. And so this is a problem that we've actually had before. The Pentium G3258, we bought one. We were getting ready to do a video on it, but there was a Windows update that came out that updated the microcode. And this Windows update that updated the microcode would cause your Windows machine to blue screen if you had overclocked the G3258. This was a very popular, very inexpensive dual-core CPU, and Intel sold a bunch of them, and they were like, people are overclocking this, and they're getting a lot of performance out of this. Well, this is not good. Motherboard manufacturers didn't bite with the whole microcode update thing, but there was something that Microsoft encountered, or must have encountered, because Microsoft thought it was necessary to bundle a microcode update with a Windows update. And so what happened was, if you were running the Pentium G3258 and you had overclocked it, you would get a blue screen when that Windows update installed, because the CPU was sort of locked down on non-Z chipsets. So the CPU was checking to see what chipset it was running on and saying, oh, you didn't buy an overclocking Z chipset. Let me just go ahead and blue screen for you. So that was probably intentional, but at the time it's like, well, there's not a lot of info here. Nobody wants to talk about it. The partners that we have in the hardware industry didn't really want to talk about it because they don't want to anger the 800-pound gorilla that's Intel. But now it's happened a second time with these non-K part Skylake machines. Here we have another, it's like board manufacturers figured out a way to do the overclocking, and it's the base clock overclocking, even though the rest of the CPU is locked down. And here we have Intel getting ready to release another microcode update, and you can not run the microcode update, but if it becomes part of a Windows update, then you have to not install that Windows update or you get a blue screen. That's crazy. That's completely insane. I don't know. This doesn't taste right. This doesn't seem ethical. The deal with these Intel CPUs is that they are so complicated that there are going to be bugs, and bugs in hardware are bad. If you have a CPU that's got some sort of bug that can be exploited by software, at worst, it could cause the computer to lock up. At slightly less than worst, it would let some piece of software exploit a flaw in hardware that's not a flaw in programming in order to do privilege escalation or something like that, so that somebody could break out of a jail or break out of a virtual machine to take over the entire computer, to take over the entire machine. This is really bad news. Intel actually encountered some problems like this early on with the Pentium. There was a particular bug called the FOOF bug, and there was also an FDiv bug, and these bugs were basically catastrophic. Certain types of calculations would return incorrect results. Other types of calculations would cause the CPU to hard hang And there was not really a mechanism for Intel to fix these problems with the CPU other than just replace the hardware, which of course is insanely expensive for people that encounter those problems and wanted to, have their hardware replaced. So a mechanism was introduced in subsequent versions of the Pentium processor that became known as microcode. And so microcode is almost like a little bit of executable code that runs on the processor that looks for certain situations that might be happening with the hardware on the processor, and if there are bugs or if there are problems or whatever, the software sort of prevents it from being a problem. And so like if the if we're talking about the floating point calculation problem for a particular kind of floating point, the Pentium would return a wrong result. The microcode is sophisticated enough to look for that type of calculation and do something to that to manipulate that type of calculation so that it returns the returns the correct result. Basically, the microcode, if you think about it, that type of functionality that exists even underneath the operating system could be exploited for nefarious purposes. Well, Intel realized that as well. The microcode has to be cryptographically signed on modern CPUs, but it is hugely flexible. And so, somebody like the NSA could mess with your random number generator by having a signed microcode update, for example, and so detect when your CPU is logging you in or detect when your CPU is doing something. And they could do something with the microcode to sort of subvert your operating system. So the microcode is a really hugely powerful thing.
So one of the big problems that I have with this is it's really the consumer's choice, wouldn't it be? And it seems like what they're doing is anti-consumer, and it's just purely for their own marketing purposes and their own wallet, I suppose. But now they're going to force those people who were overclocking to buy a K part. And I know you're voiding your warranty, but it's the consumer's choice to do so.
Yeah, I mean, if you go back far enough, you always you had to set your CPU clock. I mean, I remember back in the day with my old Pentium, whatever. I had like a P500 megahertz or something. And if you got the motherboard that could do it, you could tweak out and adjust your front side bus. You could adjust your core clock. You could do all of these kind of things and overclock your CPU. This was all before the K parts. This was all before any of that stuff.
Every CPU you had to go in and do it manually almost.
A lot of those you had to just go in and manually tweak it, or your memory wouldn't be the right speed, and you had to tweak all those settings, which kind of was a little complicated and a little annoying at the time. But you could always just go in and, well, what happens if I just adjust this a little bit higher? You burn out the chip, and you're like, oh, you're out the money. And I guess with the K parts, you're paying a couple of extra bucks for the purpose of not voiding your warranty if you blow up your chip. I mean, ultimately, they shifted and changed based on consumer habits. They shifted and changed their marketing stance on a lot of this, and then they started pushing out all these different various chips. I mean, like I said, AMD's done a lot of similar stuff. I'm like, what was the black edition versus the non-black edition? What was the difference there? Well, I mean, you've got the 8320, the 8350, and the 8370 are all the exact same chip, except they've been binned differently. So the 8370s come out the gate with a slightly higher clock, or the 8370Es come out the gate with a lower clock to save power, but they're still the exact same chip.
Lower TDP, yeah.
I mean, it's all the same chip. Like, they are physically the exact same chip off the wafer board. So I'm
okay with binning. It's a sort of a silicon lottery thing. They know that this chip is better for a certain frequency, so they're going to sell it at a little higher price and then guarantee that it'll hit a higher turbo or whatever. But what Intel does is seems to be just purely marketing.
My personal opinion of this is that there's a little bit of dishonesty in this statement from an Intel spokesperson in this PC World interview. It said, Intel regularly issues updates for our processors, which our partners voluntarily incorporate into their BIOS. An Intel spokesperson said, the latest update provided to partners includes, among other things, code that aligns with the position that we do not recommend overclocking processors that have not been designed to do so. Additionally, Intel does not warranty the operation of the processor beyond its specifications. So how does the microcode update work? For starters, it will only work if you want it to. If your motherboard currently supports overclocking, then it will continue to do so until you update the BIOS. Well, that's not actually 100% true, because we already experienced on the Intel Pentium G3258 that the microcode updates came from the Windows operating system, not from the BIOS. And so even without updating your BIOS, the operating system can push a microcode update. So that's not the whole truth of the situation. And so I think that it would be nice if we could get a microcode update that divorces bug fixes from, oh, this doesn't align with our expectation that this is how this should be used. It's like you sell physical hardware. I'm sorry, you don't get to dictate, especially after the fact, how it's used. You can't sort of say have a piece of hardware that works one way and sort of change the way that it works. Yes, I suppose you have the option to continue to run the old microcode, but it's really annoying and weird for the user if they're having to deal with operating system updates that push those microcode updates. You're going to have to run an old BIOS with an old microcode. Possibly ASRock and other companies could build options into their UEFI that say, oh, use the latest microcode or use this specific one that allows more overclocking. That would maybe be a thing. Maybe the UEFI can block microcode updates from the operating system. That might be a possibility. I'm not sure.
But Intel they're not gonna stand for that.
Yeah.
I mean,
it just doesn't seem ethical that Intel would make this decision on behalf of the user. It just, it just doesn't.
I think the other piece of this is when you're doing a BIOS update, 90% of the time I've ever done a BIOS update is because it's fixing a bug, like I said, divorcing bug fixes from this kind of stuff, but it either fixes a bug or it adds extra functionality.
Maybe you needed to enable a newer type of hard drive or something, or
something,
whatever.
Something.
Something's not working.
But even then, you're talking about how the operating system can enable and do some of these crazy microcode updates. But what happens if you run into a Windows 10 update that says, oh, you're running an old version of the UEFI. We need you to update that, otherwise everything's going to break. We can't operate on this old version of the UEFI because of these fixes that have gone in place. And they just kind of systematically paint you into a corner where you have to run the update to maintain security and functionality and what that kind of jazz. I mean,
yeah, we didn't really say anything about the G3258 when it happened because that might have been a defect in the Windows 10 update, or it might have been, a one-off situation. But things don't, we've got 2 data points now at least, and it's looking like a pattern. And this, it doesn't matter what we say, it doesn't matter what anybody in the industry says. What gets Intel's attention are the end users. So the end users sort of saying that this behavior is not acceptable is really the only thing that could cause a behavior change here. That or voting with your wallet. Is this enough of a reason to, use AMD? I don't know.
Wait for the FX to come out, really. For that to happen, I think, for a lot of people. But
the Zen chips, yeah.
I think the Zen chips. I'm just gonna call them FX because that's my brain is like, oh, the next cool thing. But yeah, the bottom line for me on this is that it's just a plain and simple. It's a dick move, and that's just what Intel's done.
By the way, if Intel was ever going to sponsor us, they're never going to sponsor us now.
Yeah.
But that's really, okay, because we love you guys.
Yeah. We just blew all of our future sponsorship chances with Intel and with Comcast, obviously. But, so yeah.
Well, Intel hasn't screwed up this bad since the Celeron 300A. For those of you that don't know, the Celeron 300A was a 300 megahertz Celeron that was, its bus clock. Well, its bus clock was 66 megahertz, but if you overclocked it to 100 megahertz, then the CPU clock became 450 megahertz. And so, Intel really locked down the multiplier on the Celeron 300A, and, you could not, there was nothing you could do, really. You could, but it was crazy. But with the Celeron 300A overclocked to 450 megahertz, that thing was crazy. And they also forgot to turn off the thing that lets you run those in a symmetric multiprocessing configuration. I myself had a dual Celeron 300A machine, I think, if I remember correctly, and that thing ran like greased lightning. It was crazy, and it was like, man, I can't believe Intel actually let this happen. And later Celeron 300As had taken more steps in hardware to sort of stop you from doing those kinds of things. But there were a bunch of Celeron 300As that actually would run perfectly fine in an SMP configuration, which is completely insane because that was designed to be a low-end chip. So I don't think Intel has screwed up this badly since the 300A.
Well, even then, when they didn't have the mechanisms to say, oops, our bad, and reverse that with this kind of thing. So they actually had to silently just start releasing the next version of the Celeron, A chip and push it out the door with like, oops, my bad. So let's, you buy a new one, it wouldn't work. You bought an old one and you had to go find one of the old ones that had a certain serial number on it. And...
Anyway.
Yeah.
That's...
It's like, and it's really unfortunate too because the people that got the Pentium G3258 on ARC says it doesn't do turbo boost, but it actually does do turbo boost pretty well. It's only a dual core thing, but man, it's really fast if you overclock it. So, You know, I feel bad for the people that have gotten the non-K parts, and especially the Xeons, and they have been able to overclock them, but the microcode updates are really going to lock it down, and that's really, really unfortunate.
That's pretty much it, guys. Let us know what you think in the comments, and head over to the website, grab a t-shirt, because Intel's never going to support us, and you get a cool t-shirt. So that's
yeah, I mean,
much it.
come on, these things are awesome.
I think it's neat. I would wear it. All right, we'll see you guys in the comments.